طيب بسم الله والحمد لله والصلاة والسلام على رسول الله وعلى آله وصحبه وله. Any questions يا شباب before we proceed? Any questions? طيب. Okay, so let's continue with that section on section 7.2, and let's now talk about conditional probability and independence. Conditional probability and independence. So let E and F be events with probability of F greater than 0. Probability of F greater than 0. The conditional probability of E given F, denoted by probability of E given F, is defined as the probability of the intersection of E and F divided by probability of F, divided by probability of F. So basically, what does this say? Well, this says the following: that if I have two events, if I have an event E, and I know that event F has occurred. I know that event F has occurred. What's the probability of E occurring if I know that F has occurred? Okay, if I know that F has occurred. So this formula gives us that the probability of E given F is probability of the intersection divided by the probability of F, of course, given that the probability of F is not 0. Okay, the probability of F is not 0 because we said that F has happened. Sorry, we said that F has happened. Right. Now, the other thing related to this is the independence of E and F. When do we say that two events are independent? Well, we say that two events are independent if and only if probability of the intersection of the two events is the product of their individual probability. So probability of E intersection F is equal to the probability of E multiplied by the probability of F, multiplied by the probability of F. Right. Now, I would like you to look at this and tell me, do you see any common thing between these two definitions or these two statements or these two theorems? Yes?
They are independent. The probability of E given F, it would be the probability of E only.
Aywa. Did you notice here that probability of E intersection F is by definition probability of F multiplied by probability of E given F. صح؟ طيب. If they are independent, the probability of E intersection F is also probability of F multiplied by probability of E. So what does that say? Well, this says that if E and F are independent, what's the relationship between the probability of E given F with probability of E? They are equal, which means that the occurrence of E is independent of F. The occurrence of E is independent of F, right? So basically, as one of your colleagues mentioned in the previous section, if I have two events, how can I see whether they are independent or not? Well, there are two ways. One way is find probability of E intersection F and check whether it is equal to the product of probability of E times the probability of F. So this is one way. The other way is if you are given the probability of E given F, somehow if you know what is the probability of E given F, if it turns out the probability of E given F is the same as probability of E, you will also conclude that E and F are independent. You will also conclude that E and F are independent. So let's take some examples. Let's take some examples on this. Right. A bit string of length 4 is generated at random so that each of the 16 bit strings of length 4 is equally likely. Okay. The question is, what is the probability that it contains at least 2 consecutive zeros given that its first bit is a 0? Given that its first bit is a 0. طيب. Now, who can tell me what is E and what is F in this case? E is the event that the 4-bit string contains at least 2 consecutive zeros, صح? So let's call this E. And what is F? Its first bit is a 0. So this is my F. And what do I need? I need to find the probability of E given F, صح? This is what is wanted. This is what is wanted. طيب. So in order to find probability of E given F, basically I need to determine what is E and what is F, صح? طيب, الsample space عندي how many outcomes do I have? 16, صح? So let's list all these 16 outcomes. ايش رايكم? Let us list all these 16 outcomes. So what do I have? 0, 0, 0, 0, 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1. And let's, on the other side, put basically 1, 0, 0, 0, 0, 0, 1, 1, 0, 1, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, and the last one is 1, 1, 1, 1. Okay, so this is my sample space. Now, E, I'm gonna use the letter E to the left of the outcome when it is satisfied. So what is E? Contains at least 2 consecutive zeros. So ايش رايكم? Does the first one match this? This one, third, the fourth, the fifth, the first 5, صح? كلهم they belong to E. طيب واللي بعده? No, 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 صح؟ طيب let's go to the other side. Yes ولا no? Yes, yes, no, no, yes, no, no, no. Okay, so these are the outcomes of E where I have at least 2 consecutive zeros. طيب, now let's do F. Now for F, what is F? F says that the first bit is a 0. Which ones here have the first bit 0? All the first column, صح? The left column. So basically, all these belong to F. طيب. So now, according to the definition, the probability of E given F is probability of E intersection F divided by the probability of F, صح? طيب. Now, let's compute what is the size of an event E, what is the size of an event F, and what is the size of an event E intersection F. What's the size of the event E? 2 3 4 5 6 7 8 صح. So the size of the event E is 8. What's the size of F? 1 2 3 4 5 6 7 8. So basically we have also, this is 8. What is the size of E intersection F? 1 2 3 4 5. All of them are to the left, صح? All of them are in the first column. So this is 5. So therefore, probability of E given F is equal to what? What is the probability of E intersection F? 5/16, صح? The probability of E intersection F is 5/16. What is the probability of F? 8/16. Probability of F is 8/16. What is this equal to? 5/8. طيب. Look at what I have put here. Can anybody see where is the 5/8? ها؟ شايفين يا شباب؟ ترى. So basically here, what do we have? We have event F, which is represented by all these outcomes, has occurred, صح? Given that this has occurred, given that event F has occurred, what is the probability of event E, which is having 2 consecutive zeros? Well, since in this column we have 5 outcomes that have 2 consecutive zeros, at least 2 consecutive zeros, then the probability is 5/8, which is exactly the same as what we have. واضح يا شباب? Is that clear? Yes, go ahead. That was actually my second question. So my second question, are E and F independent in this case? Well, let's check. So احنا ايش قلنا؟ probability of E is 8/16. Probability of F is 8/16, which is basically half and half, صح? Half and half. طيب. Probability of E multiplied by probability of F is equal to what? Is equal 1/4, صح؟ طيب وايش ال probability of E intersection F? 5/8. It's not 2/8, صح? It's 5/8. So E and F are dependent ولا independent? They're dependent. If they are independent, the probability of E intersection F كان لازم يساوي ايش؟ The probability of E multiplied by probability of F. But that did not happen. Okay? But that did not happen. Another thing, notice that the probability of E given F is equal to what? 5/8, صح? Will probability of E 8/16. Which is 4/8, صح? So probability of E is 4/8, and the probability of E given F is 5/8. Since the two probabilities are not the same, this means that they are not independent. They are dependent. Okay, they are dependent. واضح يا شباب? Any questions so far? طيب. Okay. What is the conditional probability that a family with 2 children has 2 boys, given they have at least 1 boy? A family with 2 children has 2 boys, given they have at least 1 boy. So what is E and what is F in this case? E has 2 boys. A family of 2 children has 2 boys. So has 2 boys. This is my E. And what is my F? Have at least 1 boy. Right. So now, what is my sample space in this case? Well, my sample space is nothing but boy, boy, boy girl, girl boy, and girl girl. طيب, may I ask, why do I have boy girl girl boy? Why should I should have or I could have said just boy girl once. أيوة, who's older, صح? So here we're assuming that basically BG represents a family with an older boy and a younger girl, whereas GB represents a family with an older girl and a younger boy. Okay. So my sample space, what's the size of my sample space in this case? 4. صح? I have 4, the size of my sample space. طيب. So let's write that down. So the sample space is 4. طيب. What is the size of the event E? Well, since I have here boy, 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 girl, girl, boy, girl, girl. So let's do what we did in the other question. So E in this case is to have 2 boys, صح? This is my E. Do I have any other one that has 2 boys? That's it, صح? طيب. Given they have at least 1 boy. Given they have at least 1 boy. Which one has at least 1 boy? First 3, صح? The first, the second, and the first, the second, and the third. The first, the second, and the third. So now I'm ready to talk about what is the size of E. What is the size of E? 1. What is the size of F? 3. What is the size of E intersection F? 1. Therefore, probability of E given F is equal to probability of E intersection F divided by probability of F, which is, now what is probability of E intersection F? 1 over 4, صح? Divided by, what's the probability of F? 3 over 4 3 over 4 صح؟ 3 over F من وين اجت ال F؟ 3 over 4. What is this equal to? 1/3. Okay, so probability of E given F is equal to 1/3. طيب, let's ask again our question. Are E and F independent in this case? They're not independent. ليش؟ The probability of E given F ايش يساوي؟ 1/3. Will probability of E? Probability of E is 1 over 4. Since the 2 probabilities are not equal, they are not independent. Okay, شباب? Okay. طيب. So this is now a direct question on independence. Suppose that E is the event that a randomly generated bit string of length 4 begins with a 1, and F is the event that this bit string contains an even number of ones. Are E and F independent if the 16 bit strings of length 4 are equally likely? So in order to save time, I have listed all the 16 bit strings. Okay, I have listed all the 16 bit strings. So now the question is, I need to mark which outcomes belong to E, which outcomes belong to F, right? So which outcomes belong to E? What is E? It begins with a 1, صح? So which ones begin with a 1? All the second half, صح? All the second half. So let's mark them. So basically, I have all these belong to E. All these outcomes belong to E. طيب, F is the event that this bit strings contain an even number of ones. Now, in order from 1 to 16, which ones contain an even number of ones? ايش رايكم؟ 0 is even ولا مش even? 0 is even. So the first one to belong to F is, the first outcome to belong to F is basically the first bit string, 0, 0, 0, 0. So this is an F. طيب. Next. Well, it is the fourth, صح? 1, 2, 3. This is the fourth, right? Which has an even number of ones. طيب وبعدين 6, 7, 9, 10, 12 صح؟ 12 شلون 13؟ 13 1101. بعدين last one 16 صح؟ The last one is 16. Okay, so these are the outcomes that belong to, these are the outcomes that belong to F. So now the question is, in order to determine whether the two events E and F are independent or not, I need to find probability of E, probability of F, probability of E intersection F. طيب نعم. ايش رايك؟ It's no, go and search. It's the most even number in the world.
That's a conspiracy. I remember I had an argument with my orientation doctor about this. He said you cannot determine whether it's even.
No. It's too even.
Too even.
Yeah.
Do you have a book for that?
Well, it divides 2 without remainders, huh? You can write it as 2 times 0. You cannot be more even than that. Okay? You cannot be more even than that. طيب. So let's. Oops. ليش هيك الخط عم يطلع؟ So the size of my sample space is 16. What is the size of E? 8, صح? And what is the size of F? 1, 2, 3, 4, 5, 6, again 8, right? And what's the size of E intersection F? Well, E intersection F, we can actually 1, 2, 3, and 4. So basically, the size of E intersection F is 4. Therefore, we need to check whether probability of E intersection F, is it equal to the probability of E multiplied by probability of F. Now, what's probability of E intersection F? لا هيها موجودة قدامك. السايز تبع ال E intersection F is 4. So على طول 4 over ايش؟ 4 over 16. Is this equal to, what's the probability of E? 8 over 16 multiplied by 8 over 16. Are they equal? ما شاء الله ما شاء الله ما شاء الله ما شاء الله. They are equal. Huh? They are equal. So therefore, independent ولا مش independent? Therefore, E and F are independent. Okay. Therefore, E and F are independent. Okay, شباب. Any question? طيب. Yes.
So in these previous two examples, the length of this string doesn't actually affect the result.
No, it doesn't have anything to do with the length of the string. It has to do with the events themselves.
Yeah. So if we, for example, use 5 or 6 bits, the results would be the same thing. The chances.
I wouldn't dare to make that generalization unless I see it in front of my eyes. Yani with things with probability are not that. At least I, as a person, I'm not that intuitive with probability and statistics. I like to, solve everything in front of me. Now,
Can we say A given B without the context of probability? Like the set A given B, or does that, like, does it have any meaning? A given B without probability?
not something that I know of. Not something that I know of. But this question was solved in section 1. It's very straightforward. Let's do a little bit harder, although all of them are the same. But are the events E that a family with 3 children has children of both sexes, and F that this family has at most 1 boy, independent? Assume that the 8 ways a family can have 3 children are equally likely. So let's first put down the sample space. ايش السامبل space؟ ماني سامع. Okay, you're gonna start with girl, 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 and then girl, girl, boy, girl, boy, girl, girl, boy, boy, بعدين boy, girl, girl, boy, girl, boy, 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 girl, boy, boy, boy. Okay, so these are my outcomes. Now, what is the event E? A family with 3 children has children of both sexes. Has children of both sexes. So let's go over them one by one. What is the first one that has both sexes? Second, third, fourth, fifth, sixth, seventh, and that's it, huh? So we only have 2. The first and the last, they have only 1. The rest have both sexes. And what is F? F, family has at most 1 boy. Has at most 1 boy. Which one has at most 1 boy? First, second, third, and fifth. That's it, صح? First, second, third, and fifth. Okay? طيب. So now I don't have to write probability E or F. Let's just go directly to the probability instead of looking at the cardinalities. So what is the probability of E? It's basically 6/8. And what's the probability of F? 4/8. And what's the probability of E intersection F? Well, in E intersection F, we have 1, 2, and 3. So it is basically 3/8. So therefore, is the 3/8 equal to 6/8 multiplied by 4/8? Well, this one is what? 3/4 times 1/2 صح؟ مظبوط؟ ايش بيساوي هذا؟ Independent ولا مش independent؟ Independent. Therefore, E and F are independent. Therefore E and F are independent. واضح يا شباب؟ Okay. طيب. So now let us go over Bernoulli trials and the binomial distribution, and then we will do one example, and then we will do the activity, which is very similar to the example that we will do. So let's start with what do we mean by a Bernoulli trial. A Bernoulli trial denotes each execution of an experiment with only two possible outcomes. Two possible outcomes. For example, when a bit is generated at random, what are my outcomes? 0 or 1, صح? طيب, when a coin is so this is a Bernoulli trial. We can consider this as a Bernoulli trial. If a coin is tossed, what are the possible outcomes? Head or tail. Again, this is considered as a Bernoulli trial because it has only two outcomes. طيب, if a die is thrown, this is not a Bernoulli trial anymore because now I have 6 outcomes. I don't have only two outcomes. طيب, so what does that give us? Well, this allows us to possibly classify the outcomes as success or failure. Okay, like for example, 0, 1, you can consider 0 as failure, 1 as success, right? So a possible outcome of a Bernoulli trial is called a success or a failure. طيب, if P is the probability of success, what do we know about Q? The probability of failure. 1 minus P, صح? Because I only have 2 outcomes. Okay, so now many problems can be solved by determining the probability of K successes when an experiment that consists of n mutually independent Bernoulli trials takes place. Okay, and in order to give you a flavor of the proof of the Bernoulli distribution, let us do it based on this example. So a coin is biased so that the probability of heads is 2/3. The probability of heads is 2/3. What is the probability that exactly 4 heads come up when the coin is flipped 7 times? Assuming that each flip is independent. Assuming that each flip is independent. So basically now, what do I have? What is my experiment? 7 flips, صح? And what is my event? Exactly 4 heads. طيب. Number 1, what is the size of my sample space? To the power 7. Each outcome is either head or tail, صح? ف 2 times 2 times, so this is 2 to the power 7. طيب. In how many ways can we have 4 heads? Yes. 7 choose 4. Chapter 6 is on our tails, صح? ما في. You cannot, separate 6 and from 7. There are because the ordering is not important, صح? When you say head, tail, head, صح? In how many ways? Well, we have basically 7 choose 4. طيب, and what's the probability of each such outcome? اللي هم 4 heads. What's the probability of each head? 2/3, صح? The probability of each head is 2/3, right? So what's the probability of each such outcome? It's basically لا it's not 2 over 3 يا شباب. أنا إيش قصدي what's the probability of each such outcome? Of each 4 heads. What is the probability of the 4 heads in the 7? Because my sample space consists of 7 flips, صح? Each one is 7 flips. So each one that has 4 heads, what's the probability of each one that has 4 heads? Forget about 7 choose 4. Now I'm talking about one of them. هلا هذه ال 7 flips independent ولا مش independent? So probability of them, the probability of the outcome of the 7 flips should be equal to what? To the product of each one, صح? To the product of each one. So if you have exactly 4 heads, what is the probability of such outcome? 2 over 3 to the power of 4.
Also, we have to account for the
Multiplied by
1 over 3 to the power
1 over 3 to the power 3. صح? Each one of them is like this. So this is 2 over 3. 2 over 3 to the power 4 multiplied by 1/3 to the power 3. The first one is because I have head, 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 tail, tail, tail. What's the probability? 2/3, 2/3, 2/3, 2/3, 1/3, 1/3, 1/3. طيب. Now, since each a sample space has these all these outcomes, or not the sample space, the event اللي هو having 4 heads. How many outcomes that have 4 heads? 7 choose 4. So what's the probability of having 4 heads? Which rule should I use here? The sum rule, صح? Because it will be for each outcome, which is basically the multiplication of the 7 choose 4 multiplied by 2/3 to the power 4 multiplied by 1/3 cube. Well, I can consider it as the sum rule لأنه I have outcome E1, E2, E3 لغاية آخر واحد وال probability is basically the sum of all these probabilities. But since they are all equal, it is 7 choose 4 multiplied by this. صح? By the way يا شباب, if you substitute with 7n with 4k in here, it's as if you came up with a proof of the following theorem, that the probability of exactly k successes in n independent Bernoulli trials with probability of success p and probability of failure q, which is 1 minus p, is given by n choose k, p to the power k, 1 minus p to the power n minus k, or q to the power n minus k. Okay, so it's kind of the proof for it. Okay, it's proof.
I see this is like the same as the term in the binomial formula for x plus y to the power of n.
Yes.
So is there like a relationship or something going on?
Not that I know of. I don't know. I cannot think of any. But at least from the proof, it's very obvious how did it come from, or where did it come from. Right. So let's do this example. This is, by the way, a question, an even numbered question in your book. We are going to do part A and B, and then I will leave you to do C and D as the activity. Okay. So let's go to this question. So assume that the probability a child is a boy is 0.51 and that the sexes of children born into a family are independent. What is the probability that a family of 5 children has exactly 3 boys? يلا يا شباب. Go ahead. Huh? N is 5. 5 choose 3 to the power 3. Do you need a calculator? 0.49 to the power of 2. That's it. That's it. طيب. Who's going to give us this one? Exactly the same question. What's the probability of having at least one boy? Exactly. 1 minus probability of no boys. Of course, you could have done it, but that will be the hard way and the long way and the way where you might make a mistake. Huh? But the best way is of at least one boy is 1 minus probability of having no boys. Or, let's make it positive. 1 minus probability of having how many girls? 5 girls. يلا يا شباب. What is the probability of having 5 girls? 5 choose 5. أيوة. 0.49 to the power 5 صح؟ وبعدين 0.51 to the power 0. ترى وال5 choose 5 كم بيساوي؟ ترى ال5 choose 5 is equal to 1. 0.51 to the power 0 is equal to 1. So this is nothing but what? 1 minus 0.49 to the power 5. This is nothing but 1 minus 0.49 to the power 5. So what do you have to do? Well, what you have to do is basically part C and D. Now I'll give you the papers. Okay, Shabab? Any question? Bye. Let me close the